This is problem 2 of the equivalent resistance challenge. And first off, I apologize for the lettering. That's Microsoft Word helping me out there. This really should have been 1, 2, 3, 4 with A, B, and C there. That would have been a lot better. And also I apologize for giving you such a hard problem, 7-8 class, because I didn't realize it was so hard. We did the easy one first. But this is doable. And if you can do this, you can do anything that's coming up on the test. So the first is to give the equivalent resistance of this whole circuit. And you can't just use you can't just treat this like a parallel circuit. You can't treat it like a series circuit because it's got components of both. So one way to think through it is, let's just sort of go around here and say we've got a resistor. We've got this whole big branchy mess here. We've got another resistor. So if it weren't for this big branchy mess, if we just had one resistor in there, what we would have is 3 resistors in series, this one, and this one. And all we'd have to do is add up the resistances to get the total resistance. So what I'm going to do is take all this and figure out what the resistance of this is, and then I'll just add this plus that resistance and that resistance. So I need to get the equivalent of this. Next problem is this big mess is not just simply parallel or series. It's, there's this branch and this branch over here, so it's kind of like they're parallel, but then there's this and this in series with one another, and then this is parallel. So if I could get the equivalent resistance of all this stuff, this 6 ohm and 4 ohm and 8, and lump them together into one, then I would have one resistor and another in parallel, so I could get that equivalent resistance. And then I could use that plus 5 plus 0.5 and I'd be done. But I can't, because there's not just a resistor here. So I need to deal with this. This looks like I've got one here and another branch in series. I can't just add these up because this isn't really just one in series. So first step has got to be, I need to find the equivalent resistance of these 2 resistors in parallel. And after I do that, it's like, just imagine I'm trading them in for one resistor here. Then I'll have 2 in series here that I can add together, because that's what you do with series. And then I'll trade all these in for one here. Then I'll have one here and one there, and they'll be in parallel. And I'll find the equivalent resistance of all that, which sort of trades this whole thing in for one resistor. And then I'll just have 3 resistors in series, so I add them up. So here are the steps. First, I labeled some of these junctions just to try to make it easier to reference what I was working on. And the first thing I'm going to do is deal with this parallel part of this circuit between C and D. So by convention, the charge flows this way. Some is going to go through here. It's going to split and go like that and then go back. So my first step was to find the equivalent resistance. So R, CD, that's what I mean, the equivalent resistance of this whole thing. This is in parallel. That means there are 2 different paths that charge can take to get from C to D. So that's what makes it parallel. And the formula is 1 over the equivalent resistance equals 1 over the one branch resistance plus 1 over the other branch's resistance. So I get 1 over R equals 1 over 8 plus 1 over 4. And this would be 2/8 plus 1/8, 3/8. So 3 over 8 ohms equals 1 over R. So I just take the reciprocal of both of these, and then I get R equals 8/3 ohm, 2.67 ohms. So I could just scribble these out or draw a whole new diagram that instead of this branch right here just has one resistor that's 2.67 ohms. But I'm not going to do that because I really need to know more about the diagram later. So now, once I know between C and D is 2.67 ohms, I can get the equivalent resistance from A all the way to B. So as charge flows through here, it goes through this 6, and then I can just say it goes through another 2.67, and these would be in series. So this and this is in series. These two are in parallel, but this and this whole thing are in series. And in series, you just add things up. So from A to D, the equivalent resistance of this part of the circuit is just 6 plus 2.67. The 2.67 replaces both of these and just gives me one imaginary resistor. So now, if you can imagine, it's like I've got 4 resistors left. There's this 10 ohm up here, there's the 5 ohm there, there's the 0.5 ohm, and instead of all this, I've got an 8.67 ohm resistor between A and B on this lower branch. So that 8.67 ohm resistor and this 10, those are in parallel because there are 2 paths from A to B. You can go through this bottom part, which has a resistance of 8.67, or you can go through the top part, resistance of 10. So now I'm going to get the overall resistance of this whole big parallel branch, and to do that I've got to use this formula again. So from A to B, the resistance of 1 over the equivalent resistance of this portion of the circuit is 1 over the individual resistances that are in parallel with one another. So 1 over 10 plus 1 over 8.67. I think I said that wrong. It's the sum of the reciprocals of the resistances. So when I add 1 over 10 plus 1 over 8.67, I get 0.215. I didn't bother with trying to do this with fractions over ohms. So again, that quantity is equal to 1 over what I'm looking for. So I need to take the reciprocal of that, and that gives me 4.65 ohms. So now what I'm doing here is just taking all this stuff up here, 1, 2, 3, 4 separate resistors, and trading them in for 4.65 ohms of resistance. And that 4.65 ohms is just in series with this and this, because the charge is going to go through this, then it's going to go through this whole thing, and then it's going to go through there. It doesn't have any alternate pathways. It's not like some gets to go through here and some gets to go through there. It all has to go through everything. So this is series. So you just add them up. These are the 2 real resistors, and this is that equivalent resistance. So I get 10.2 ohms altogether for the whole thing. Part B, find the current passing through the battery. So the voltage is 9 volts, and the resistance of this whole circuit is what I just found, 10.2 ohms, and I equals V over R. So 9 volts divided by 10.2 ohms is